Hey Patriots, welcome back. Hope you had a great break. This is looking forward to a very good 2022. So just wanted to say welcome and let's get started. So this video is going to introduce you to two new terms, translation, which is a verb, and an isometry, which is a noun. And let's talk about those. So what is an isometry? That's what we're going to talk about first. An isometry, it's pronounced isometry, is what we call a rigid transformation. Now you're thinking to yourself, well, what's a rigid transformation? Now here's the technical definition. A rigid transformation is a movement on a plane. So I'm going to start with a figure. I'm going to move it around someplace on a flat figure. And when I move it on this plane, this will preserve side lengths and angle measures between the original shape and the new shape. We're going to call our original shape pre-image, and we're going to call the new shape our image. What that means, this is a fancy word of saying that the pre-image and the image are always going to be congruent. They will always be the same as each other. So the pre-image, the image I start with, if that's the pre-image, before the movement, pre-before, is going to be the same as the image, what it looks like after the movement. Alrighty? So they are always going to be the same because I keep the side lengths and the angle measures as they are. I only change location and orientation. So what is a translation? A translation is a slide. I am going to slide a pre-image onto an image. So notice we have an arrow. The arrow is pointing this way. That means I'm starting with this star. This star is the pre-image. This is where I am starting. And this is where I am ending up. So that is called the image. And the star on the left, the pre-image, is going to be exactly the same or congruent to the image. The sides and the angles do not change. They are exactly the same. That's why it's a rigid transformation or an isometry. Isometry and rigid transformation, remember, are the same thing. So there are two ways that we are going to show a translation. One of them is called vector notation. The other one is called coordinate notation. So in a vector, it looks a lot like a point, but notice those are kind of slant. They're kind of pointy. So if we have a positive x value, we are going to slide to the right. If we have a negative x value, we are going to slide to the left. Remember, x always comes first, y comes second. If we have a positive y value, we are going to slide up. And if we have a negative y value, we are going to slide down. The coordinate notation tells us the exact same thing. If we do x, so what this is saying, coordinate notation is a little different. Coordinate notation says we are starting at the point xy. This arrow means map onto. So we're going to start at xy and we're going to map onto x plus some number and y plus some number. So if we are doing x plus some number, once again, we are going to slide to the right. If we do x minus some number, we are going to slide to the left. If I do y plus some number, we are going to slide up. And if I do y minus some number, we will slide down. So that's what coordinate notation tells us. It's the same thing as the vector. It tells us which way to slide, except this time it tells us where to start. Start at a point xy, any point. X is any x value, y is any y value. And then we're going to slide on x by plus or minus, right and left, and then y is up or down. Same here. The vector notation is exactly the same, except it doesn't tell us where it starts. We're just going to look at our graph, and we're going to figure it out from there. All right, so if you have any questions, of course, come to your teacher with those questions. We will gladly answer it, and this is what we're going to hit in class tomorrow. So, Patriots, we will see you when we see you, and hope you have a great 2022.